In this video, we're going to continue our discussion with measures of dispersion. So let's take a look at another example. So now let's use the same data values from the last example, but add a data value of 0. What's the sample standard deviation? Remember, we got to be able to calculate what the mean is going to be first. So I'll do that on the side here. Remember, that's x bar because it's the sample mean. Divide by 4. And we get 63 7/75. So again, what are we doing? Data value minus the mean. Take that value and square it. Remember, we're not going to round any of this until the very end. Data value minus the mean. Square it. Data value minus the mean. Square it. Okay, take the last column, add the values, we get this. So I'm going to write out the sample standard deviation formula now. Okay, so for the numerator, that's going to be the sum of the third column. 4 data values minus 1, so that's going to be 3. And rounding to 1 decimal place, we get this. Okay, so how do we put this into the calculator? Well, I'll show this now, so let's go to the calculator and do this. Well, first off, we've got to put the data values into the calculator. So hit Stat, highlight, Edit, hit Enter. So we'll use L1, so type in a data value, hit Enter. Data value, hit Enter. Data value, hit Enter. Okay, now that we have the data values into L1, where do we go from here? Okay, go to Stat, highlight Calc, and we're going to do 1var stats. L1 is our list. Frequency list we'll leave blank. Highlight Calculate and hit Enter. So notice the X bar, that's 63 7/75, which we got. The sample standard deviation is this, looks like S of X. And remember, that was 44 2/10. Underneath, that is the population standard deviation. That looks like theta of X. And that's approximately 38 3/10. So let's check our answers on the sheet. So notice the mean is 63 7/75, just like what the calculator said, and the sample standard deviation again is approximately 44 2/10. So let's put in one more example into the calculator. So this is the data set that I will use to put into the calculator. So 70, 85, and 100. So let's put that in the calculator now. Okay, so first off, hit Stat, highlight, Edit. So we're going to highlight L1, hit the clear button, and hit Enter. And now let's put these data values in. So put 70, hit Enter, 85, hit Enter, 100, hit Enter. Okay, so again, where do we go from here? Hit Stat, highlight Calc, 1var stats. Again, our list is L1, that stays the same, hit Enter. Frequency list, leave blank, hit Enter. Highlight, Calculate, and hit Enter. So again, the mean is 85. Our sample standard deviation, remember that looks like S of X there, is 15. And then if we want to know what the population standard deviation, that's approximately 12 2/10. So let's check our answers with the paper now. So notice here, our sample mean was 85, and our sample standard deviation was 15. Okay, so is the standard deviation resistant? Well, that's going to be no, because if we have extreme values, such like the 0, the sample standard deviation jumped from 15 to 44 2/10. Okay, interpretations of the standard deviation. Standard deviation is used along with the mean to describe symmetric distributions numerically. The mean measures the center of the distribution, while the standard deviation measures the spread of the distribution. Standard deviation can be interpreted as the typical deviation a set of data values are from the mean. And when comparing two populations, the higher the standard deviation is, the more dispersion the distribution has, provided that the variable of interest from the two populations have the same unit of measurement.